Chesapeake Bay is the largest estuary in the United States. Its watershed spans more than 64,000 square miles and encompasses parts of 6 states and the District of Columbia. 3 of the 5 largest rivers in the Chesapeake Bay watershed are fully contained within Virginia: the Rappahannock River, the York River, and the James River. The Shenandoah River and the embayments of the Potomac River also fall within Virginia's borders. Tens of thousands of streams, creeks, and rivers thread through each watershed. The Bay watershed supports over 18 million people and a vast diversity of flora and fauna. This is why monitoring and maintaining the Bay's health is essential. The Chesapeake Bay Monitoring Program is a great partnership of federal and state agencies and jurisdictions. The partnership engages local governments, community organizations, nonprofits, and watershed jurisdictions to better understand what's happening in the Bay so that we can make decisions that will help improve the Bay's health. Virginia's Chesapeake Bay Monitoring Program is an important component of the overall Chesapeake Bay Monitoring Partnership. Virginia has been collecting long-term data in the Bay on a regular basis since 1985. In Virginia, Bay and tributary monitoring is conducted by trained DEQ water quality monitoring professionals and scientists at Old Dominion University, the U.S. Geological Survey, and the Virginia Institute of Marine Science. Virginia's Bay monitoring partners follow strict procedural guidelines to ensure data quality and comparability with other participating Bay jurisdictions. Quality-assured monitoring data collected over multiple decades from hundreds of stations provides the most direct measure of Bay water quality conditions and biological responses. This data helps us understand where we need to reduce nutrients and sediment coming into the Bay and by how much. Monitoring data also helps us focus where to put restoration efforts. Additionally, monitoring data helps us understand how well we are doing to meet the sediment and nutrient reduction targets to restore Bay health. Virginia's Chesapeake Bay Monitoring Program is funded, operated, and maintained through a long-standing state-federal university partnership and includes 5 monitoring networks: main stem water quality monitoring, tributary water quality monitoring, non-tidal trend network monitoring and river input monitoring, shallow water habitat monitoring, and living resources monitoring, which includes benthic and phytoplankton monitoring. Each component of Virginia's Bay Monitoring Network has been designed to support the Bay jurisdiction's assessment of the Chesapeake Bay water quality standards. The data produced meets the 2014 Chesapeake Bay Watershed Agreement goal to evaluate the effectiveness of actions to reduce nitrogen, phosphorus, and sediment pollutant loadings from the surrounding watershed. Nutrients contribute to excessive algae growth and decomposition, which can deplete dissolved oxygen that aquatic life needs to survive. Sediment suspended in water column blocks light that underwater grasses need to grow. Let's take a closer look at each of the 5 Bay monitoring networks.
The Chesapeake Bay Main Stem Monitoring Program uses a fixed station strategy with sites distributed along the mid-channel waters of the Bay. The monitoring is conducted by Old Dominion University and includes 27 sites located from the eastern shore's Pocomoke Sound to the mouth of the Chesapeake Bay. Sampling occurs monthly throughout the year except in June, July, and August, when sampling occurs twice per month. Sampling is coordinated with Maryland's main stem monitoring schedule to provide a synoptic picture of the Bay. Whenever possible, all 27 stations are sampled within a 4-day period during each sampling event. At each of the 27 stations, vertical profiles of in-situ water quality measurements are made using instrumentation and standard operating procedures approved by the Chesapeake Bay Program's Data Integrity Workgroup. Physical measurements of temperature, pH, salinity, specific conductance, and dissolved oxygen are obtained by a probe every meter to a depth of 15 meters, then every 2 meters to a depth of 1 meter above the bottom. Light penetration is determined through incident radiation and Secchi disk measurements. Chemical parameters, including a suite of nutrients and sediment, are obtained from the surface and the bottom at all sites and from above and below the picnic line at a few select sites.
The Tributary Monitoring Program was established in 1988. Monitoring is conducted by DEQ and consists of water quality sampling at 32 stations and major tributaries to the bay and 12 stations on the Elizabeth River and its tributaries. Monthly sampling at each station is coordinated by the DEQ regional offices in an attempt to sample entire tributaries on the same day. Weather permitting, sampling occurs consecutively with the James River Run conducted first each month, followed by the Rappahannock and Elizabeth River runs, and lastly, the York River Run. At each station, physical measurements are collected at 1 meter intervals, starting from 1 meter above the bottom, working toward the surface. These parameters include depth, dissolved oxygen, light penetration measurements made via Secchi disc and incident radiation, pH, salinity, specific conductance, and temperature. Chemical parameters are obtained from surface and bottom depths at all sites and include the same general suite of parameters for dissolved and suspended nutrients as collected in the main stem. The River Input Monitoring, or RIM program, was initiated in Virginia in 1988. The RIM program aims to characterize the loads and concentrations of nutrients and sediment loads to the bay from the non-tidal watersheds of the major bay tributaries. Initially, the program consisted of routine monthly monitoring and targeted storm events at one site on each of the fall lines of the James, Rappahannock, Appomattox, Mattaponi, and Pamunkey rivers. Since that time, the non-tidal monitoring program has expanded to include additional sites beyond the fall line stations for a total of over 30 sites in Virginia. All sites used for load estimates within the network have stream gauges co-located with the sampling site and require 8 storm samples at each site from at least 2 storm events. Selection of sites is also prioritized based on location to the outlet of rivers draining the major river basin, locations delivering the largest amounts of nutrients and sediment to the Chesapeake Bay or its tributaries, importance to watershed modeling efforts for closing areas of large data gaps, such as in the coastal plain. Physical measurements collected at each sampling event include dissolved oxygen, pH, specific conductance, water temperature, turbidity, air temperature, and barometric pressure. In the non-tidal program, water samples are composited by collecting water vertically through the water column at equal intervals across the width of the stream. The specialized equipment used for composite sampling is selected based on the stream flow rate and conditions at each station. Composite samples from 6 RIM sites on the James, Appomattox, Mattaponi, Pamunkey, and Rappahannock rivers are analyzed by the state lab for an expanded suite of parameters, which includes the regular nutrient parameters from the other bay monitoring, with the addition of particulate inorganic carbon and phosphorus, particulate carbon, dissolved organic carbon, and suspended sediment. At all remaining sites, each composite water sample is analyzed for a reduced suite of dissolved and suspended nutrients. To ensure that protocols are being followed consistently across DEQ regions and among monitoring partners, DEQ and USGS coordinate to provide regular training and field audits.
A nearshore monitoring component was initiated in 2003 to monitor shallow water habitats. The program consists of the deployment of continuous monitoring devices fixed to a dock or buoy, as well as data flow cruises that track throughout main stem and tributary bay segments, collecting data as the boat is moving through the water. The monitoring is conducted April through September each year. The program was originally designed to rotate through Virginia's major tributaries and bay main stem segments on a 3-year basis. Beginning in 2024, the shallow water monitoring program will be used to enhance a Chesapeake Bay-wide continuous monitoring network where each major tributary will be monitored annually on an ongoing basis. For almost 50 years, living resource monitoring in the Chesapeake Bay has been identifying species composition and abundances of phytoplankton and picoplankton and benthic organisms in the main stem and its tributaries. The Chesapeake Bay is a plankton-driven ecosystem, the most important of which are algae, the primary food and oxygen producers, and the basis of major food webs in these waters. Identification of algae in the bay requires knowledge of species from freshwater, estuarine, and marine populations. Using a consistent identification protocol, the Living Resource Program provides a long-term historical data set that may be used to identify shifts in available food sources. For example, predominantly diatom populations, which are the preferred food source for filter-feeding fish and zooplankton, may shift to predominantly blue-green algae under nutrient-enriched conditions. During algal bloom events, the monitoring program provides information on the seasonal presence and abundance of potential toxin-producing algae and has provided information on whether these potential toxin-producing species are producing toxins in excess of established thresholds. Benthic organisms are important secondary producers, providing key linkages between primary producers like phytoplankton and higher trophic levels like crabs, bottom-feeding fish, and water birds. Benthic organisms are among the most important components of estuarine ecosystems and may represent the largest standing stock of organic carbon in the Chesapeake Bay. Some benthic organisms, such as hard clams and soft-shell clams, are economically important. Others, such as polychaete worms and shrimp-like crustaceans, contribute significantly to the diets of economically important blue crabs and bottom-feeding juvenile and adult fish, such as spot, croaker, striped bass, and white perch. The Chesapeake Bay Estuarine Benthic Macroinvertebrate Monitoring Program has complementary objectives to those of the 2014 Bay Agreement. That is, benthic monitoring serves to characterize the health of regional areas of the lower Chesapeake Bay as indicated by the structure of the benthic community, to conduct trend analyses on long-term data at fixed point stations to relate to temporal trends in the benthic communities to changes in water and/or sediment quality. The trend analyses are updated annually as new data are available. And finally, to warn of environmental degradation by producing a historical database that will allow annual evaluations of biotic impacts by comparing trends in status within probability-based strata and trends at fixed point stations to changes in water and/or sediment quality. In Virginia, 21 fixed point stations are sampled for benthic organisms annually in September, and 100 probabilistic sites are sampled once per year over the course of the summer.
The waters of the Chesapeake Bay and its tributaries have been monitored for several decades, providing data to direct management actions on the ground and to inform the public on how well the Bay partners are doing in meeting restoration goals. DEQ and its Bay monitoring partners are constantly refining monitoring procedures and strategies to ensure that high-quality data are collected to meet the Bay Agreement objectives. The physical parameters such as dissolved oxygen and temperature and nutrient and sediment data collected represent many of the key measures of water and habitat quality for living resources such as fish, crabs, and oysters. Anyone who has ever pulled a catch from its depths, skimmed the surface, walked along the vast shoreline, or through the myriad towns dotted along the coast understands that the Chesapeake Bay is an ecological gem. Monitoring the nation's largest estuary is essential to understanding, improving, and maintaining the health of this national treasure.